Okay, 43 now. Let's graph this. Okay, so here we go. So the first equation is y equals sine x cubed plus 2, y equals tan x equals minus 1.5, and x equals 1.5. So let's draw these. I wonder if I can draw them all at once. Yes, I can. So, yeah, it's a bit hard to see. So it's between these lines, this curve and this curve. It would seem like this 1.5 is a bit redundant though. Because, but, doesn't seem to be any finite area. Looks like here just, but that's from minus 1.5 to this point here. So, okay. I don't think this is solvable. We'll have to have a graphing calculator solve this equation. Sine x cubed plus 2 equals tan x. Solve expression from real numerical bounds from 1 to 1.5. 1 to 1.5. Yeah, okay. So how many decimal places are we supposed to use here? 3 decimal places. So that's 1.232 in the picture here. So it's the integration of sine cubed x plus 2 minus tan x from a to b, where a is minus 1.5 and b is 1.232. 232. Okay, dx. Right. So I should separate this out. This is a to b sine x, sine squared, which maybe I should change into 1 minus cos squared x plus 2 minus tan x dx. So that would be a to b sine x dx minus the integration of sine x cos squared x dx plus the integration of 2 dx minus the integration of tan x dx. Right, okay. Well, the sine we know, that's minus cos x with the limits. This one here is, let me think, the derivative of cos cubed x is 3 cos squared x minus sine x. So what I'll do is I'll put the minus on the inside with a 3 and a third on the outside. So you can see quite clearly that this here is the derivative of cos cubed, because that would be minus 3 cos squared sine x. So then the next one here would be plus 1/3 cos cubed x a to b plus 2x a to b. And then let me think about what tan is again. It's something like log sine, is it? Let me think. or log cos actually, log cos x, the derivative of that is cos x and then minus sine x. So that's minus tan x. Yeah, so if I put the minus inside, so log cos differentiates to minus tan x. So then this becomes plus log cos x a to b. So let's put the b in first, which is 1.232. Okay. So that is, and then minus cos that value plus 1/3 cos that value plus 2 times that plus log cos that value. So that's 1.0377 minus, and then that's minus 1.5. So that's minus 5.7119. So in total, that's 6.7 or 96. So 50. Let's check the solutions at the back. Let's see what we get. Solutions 6, and then this is number 43. Solutions, and then number 43. Come on, 43. 7.523, and I got 6.750. So it's actually quite close. Enough that makes me think maybe I made a small mistake. I wonder. 7.523. I wonder what you'd get if you went up to 1.5. Let me see. So if you went up to 1.5 instead of 1.232, what would you get? Check in. That would be 0. Oh, that would be less, which, oh, because it's flipped around. Yeah. So okay, so it's a tiny bit off. It's a tiny bit off. Let me check again. 1.232. Let's see. That is right. Okay, and then minus 1.5. So that's 6.75. So where could I have made the mistake? Let's check our calculations. Sine cubed is sine times sine squared, which is 1 minus cos squared. So that's sine x. And then the minus and the plus makes the minus, and the 3/3 cancels, and that's minus 3 sine x cos squared x, and the derivative of cos cubed is 3 cos squared minus sine x. So that does become cos cubed with the third in the front, and that looks like minus cos x. And then the 2 looks like it becomes 2x, and then maybe it's a mistake here, minus tan x, and the derivative of log cos You put cos on the bottom, and the derivative of cos on the top, which is minus sine, so that's minus tan. So that does look like log cos, although I guess this needs to be absolute, but that's fine because it was still positive. So maybe I typed it in wrong. Minus cos plus 1 over... I typed it in wrong. That is the reason why. Yeah, okay. So this is just me mistyping on the calculator. The cos cubed part. Okay, that's good. That's good. It's good to know. Okay, 1.232. So that is 1.0377 minus, oh, this is looking similar, minus 1.5. This is looking very similar, 5.7119. That's 6.75. The answer is 7.523. And let's see if I typed it incorrectly. Minus cos, yep, plus 1 over 3. Why did it change again? Yeah, sorry, it's my calculator acting up. It's been a bit weird. That's 1.0423. And then this one here, 1.04232 minus, and then let's carefully type in the next one. Minus minus, so plus 5.7194. That doesn't really help. 6.762. Minus cos plus 1/3 cos cubed plus 2 times x plus log cos 1.04. Okay. And then minus 1.5. 5.719. Right, let's check what it says in the software here. So sine x cubed plus 2 minus tan x. Integrate definite lower limit minus 1.5 to the upper limit of 1. Well, actually, you know what? I think I've just realized. Yeah, that's the same as what I'm getting. I just realized I'm assuming this hits it at. No, I would have to hit it at 1.5, but it doesn't actually hit it there. So it's a bit weird, this graph. Let's see if I zoom out, if that helps. Yeah. Unless we're supposed to include this piece too. I guess so, actually. If we include this extra piece, that probably is what's going on here. But then it's not. I guess, yeah, I guess I'm a bit thrown off by this 1.5, but I guess it's actually these two bounded regions rather than a single bounded region. So let's calculate the extra piece. So the extra piece, it's the curves have swapped places, so it's just a sign flip. So it's basically going to be the same integration, but just multiplied by minus. But then it's 1.23 to 1.5. So if you just repeat but put in the different values and multiply by minus, let's see what we get. So 1.5 and multiply by minus, so that's 5.7194 minus, and then 1.232, and then that's, no, that's too big actually. I'm doing something wrong here because that extra piece looks quite small. Okay. So it'd be this at 1.5 minus it at 1.232. But I think the problem is this looks like it goes up to infinity at 1.5, but actually doesn't quite. So no, it's okay. So it is finite. It is bounded. Okay, that's good. 1.5. Yeah, okay, sorry. Calculator's acting up. So that's multiplied by minus. So that's minus 0.28059 minus, and then plus 1.04232. So that extra piece is 0.7617. So that's that piece there. And then if I just put an extra 7617. So the total now for the two pieces, this piece and this piece, is 7.523. 7.523. Okay. So yeah, it was this region and this region is what they were looking for.